Good morning. It's another day in the physics classroom here, teaching online grade 11 physics. Anyways, we're continuing with the uniform acceleration questions, VT graphs. So we're going to look at type 3 and type 4 today. I'm going to call those. We're just working our way through the different combinations. We have seen the combination of information given, where you have given the initial and final velocities and the time. It's kind of the most straightforward one because it's just a regular acceleration question to start with, and then the added bonus of figuring out how to get the displacement. And we mixed it up a little bit and gave you the initial velocity, the acceleration, and the time. Of course, calculating the final velocity, again, is just an acceleration question with the added bonus of finding the displacement. Here, I guess we could call it the same kind of thing, right? With type 3, we're going to give you the final velocity, the acceleration, and the time. So obviously an acceleration calculation can just give you the initial velocity with the added bonus of getting the displacement. And then the last one, we're going to have something a little more new, the type 4 for today. Initial and final velocities and the displacement, and then you need to work backwards and try to figure out what the acceleration must have been and how long it must have taken. Okay. Again, just to be clear here, though, in the end, one of the ways you're going to be able to do this is literally just circling what you have, picking the equation with all 4 in it, and going for it. Okay, but we're going to do VT graph methods as well because it really helps support understanding of what's going on. And I will require do this one by the VT graph method. Okay, so just be aware of that. So type 3 here. So we got a vehicle slowing down at a rate of 3 meters per second squared for 4 seconds. Ended up with a final velocity of 10 meters per second forward. Determine what its initial velocity was and how far it traveled during the 4 seconds. So if you're looking at the given information, we were given the acceleration rate, slowing down at a rate of, so we're assuming forward is positive, and so negative, that goes in as negative. We're given the time interval of 4 seconds, and we were given the final velocity of 10 meters per second forward. So again, it's understood here that the positive means forward. You don't have to state it all the time in questions like this. And we're asking for V1 and displacement. So a good thing to do as part of a question like this, just to understand what's going on, is the VT graphs, plus we're going to use it for displacement, right? So as part of this question, if you're solving this by VT graph method, it would be draw the VT graph and show using it to determine the initial velocity and the displacement. So we're starting at an unknown velocity. We're slowing down to 10, right? And so your graph is certainly going to have a starting velocity and a final velocity kind of thing going on, right? So starting at an unknown V1, ending up at 10 after 4 seconds, nice straight line because we're talking about uniform acceleration and so on. Notice here, I didn't say accelerated with uniform acceleration. It just starts to be just understood, accepted as this is what we're doing, okay? So that's a good VT graph. I even jotted in there the idea of the delta V, but I don't need to have. That could have been your VT graph to start with. If you're playing the game of pausing and trying things yourself to be an active learner, that's maybe that's what I hope you would have. So, like I've been doing on the other questions, I had to modify them a little bit to make it happen, but this one's ready to go. Should we start with the acceleration slope concept or the area displacement concept? And because we have this one, right? So we have this one, and so we're going to use, of course, right? Definitely think of that as a good guide to get started on these questions. Use what you've got, right? And so if we start out with acceleration equals delta V over delta T, or slope on a graph, right? You don't need to think of it as slope, but it really is slope. So we put in your V2 minus V1, and so you can find we're going to be able to put in the acceleration, the V2, and the time. The only thing missing is going to be V1, and so we'll solve for it, right? Plug them in, multiply both sides, subtract both sides by 10, end up with negative V equals negative 21, negative 22, sorry. So when we divide out, you end up with a positive 22. So if at first you get this negative 22 answer and you're thinking, my goodness, I can't have slowed down from negative 22, that's just because you're jumping the gun a little and you realize, oh, wait, I have to finish solving. I get this is 22. So I certainly could jot this on here as 22 from the calculations, right? And then we can continue on, and then we can tackle the displacement by using area. And so again, we've got a triangle right there. I'll trace it out, and a rectangle. And so we can just do the math. We have 1/2 the base times the height. The height is from 10 to 22, right? So the height of the triangle, right? The height of the triangle is this like 22 take away 10. So that you can tell it's 12, right? So that's really this delta V, right? We had the delta V. If we were to look at that number, we didn't do it or need to do it here, but delta V itself would be like V2 minus V1. And so we'd have the 10 minus the 22, which should be negative 12, right? So delta V is negative 12 meters per second. We slowed down by 12, right? But in terms of heights of a triangle, because we're going forward, we're going to use that as a positive 12. Okay? So we've got that in there as positive version of this thing. So the positive 12, we got the 40 times the 10 for the rectangle. That becomes a 2, so that's 24 plus the 40 gives us 64 meters. So therefore, the final velocity or the initial velocity was 22 meters per second, and the displacement was 64 meters. All of those forward. Okay, so hopefully that seems fairly normal, right? It's just a slightly different place the numbers got put in because we're given slightly different things, but I don't think that feels a ton different than types 1 and 2. But it is really a different combination, so it's technically a type 3. My intention of the types is 2 things: to space this out so we have time to get really good understanding of all this, but also if you're looking at trying to tackle a question, and it's obvious that it's a type 3, either because you know that if you're given acceleration time in V2, you know it's a type 3, or you look at a table like this that I have available for you, you can go and look at a type 3 example in the lesson and know that you're looking at the right stuff and trying to learn from it, right? Rather than trying to mimic a wrong type of question, in which case it doesn't lead to good things, of course, right? So type 3 with equations. So the neat thing about the equations is, of course, they're pretty powerful, and it turns out you can do either first. So we had to work with acceleration and get V1 first, get V1 and delta V first, basically, then do displacement. I'll show you that you can actually go ahead and do displacement first. Okay, so let's backtrack a little bit here, and we'll circle what we have and pick an equation, right? So acceleration is something we're working with. Time, working with, just circling the ones where there's the axis because that's in the equations, right? V2, final, same thing. And then if we're looking for displacement first, then we circle, 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 and we pick an equation that has all that stuff. So that's the one. So it's V final times time, so V2 delta t minus 1/2 acceleration delta t squared. Okay. So that's the equation we pick out from it. And we just plug numbers in and get our answers. Okay, so boom, 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 plug numbers in, end up with the 64. End up with 2 negatives, make a positive. As we go, we get 64. Just healthy to look at understanding how this makes sense. We're looking at doing the 10 times the 4. So it's just we're adding it on. I guess there's not really much to analyze by logic. I was thinking of this as like, you could think of it as the whole rectangle, take away the other piece, but that's not really actually what happened here. So I should get rid of that. That would be a way to calculate, though, of course, right? We could have an equation that would be the V1. Oh, actually, no, never mind. It is right, because the there's another version we could have used for this. Sorry, I'm just losing track of which version we've got here. But if this was V1 and slowing down and so on, if that's the equation we're going to use, like the V1 delta t business, we'd have to subtract the bit out. So it feels kind of like that. But anyways, let's just erase that. And so if we're looking for V1, we can then maybe do a redo here. So we're not working with displacement anymore, so I'll get rid of those ones. And instead, we'll look for V1 and see which equation we've got all of the bits and pieces for, which is that top one, right? And so now we can just go ahead and do the calculations essentially the same as what we did in the first page, right? So that is type 3. Type 4. So type 4, I said in advance, is going to be V1, V2, and displacement given, right? So here we go. Boat increases velocity from an initial velocity to a final velocity. They're both given while traveling this distance apart. So a boat travel, starting, you look at the speedometer as you're going past the first buoy, the first marker, you're going 2 meters per second. And then when you get to the second one, you're going 6. And if you know they're 8 meters apart, you could calculate all the missing pieces, right? So you would have been given this information and you'll be able to calculate what your acceleration is and how long it took. And then you could confirm based on the measurement if you took the measurement itself and so on. So let's do a VT graph for this one. This one from scratch with you. So we're looking at an initial velocity of 2. So V1 equals 2. Final velocity 6. And this is our VT graph. We don't know how long it took, but we do know we started at this velocity and we ended up at this velocity after a certain amount of time. And we know that we accelerated at a uniform rate because that's what that's what we're doing in this class, right? All about uniform acceleration. So that's what I have labeled on there so far. We could also point out that the displacement, delta D, equals 8 meters. And I like the idea of like labeling it on there like that, or you could even go as far as saying like, like this, like the area, just to help guide your knowledge and whatnot, right? And so as usual here, you're looking at saying like, are we looking at acceleration equals delta V over delta T as a slope concept if you wanted to think of it as slope? Or are we looking at displacement and area? Which one are we working with? Well, again, you've got this one, and so you're going to use it, right? You've got it, you can use it. So let's do this. We've got our displacement equals, and we've got a rectangle and a triangle as usual to guide our process. And so we've got an unknown time here, delta t, as a base. So we've got a delta t times a 2 for the rectangle, and then that same delta t for the base of the triangle, 1/2 of the delta t that we don't know, times the delta v, the height that we do know, right? So delta v obviously on here is the height of the triangle, which is the 6, take away the 2, which is 4. Right? So height of the triangle, if you wish, you could write it in like that or whatever, but that's a 4. And then the other thing, of course, we know is the total area. The displacement is 8. Right? So notice there's only one unknown here. We just have to solve for it, right? So now we have to just solve for delta t. So here's a real life representation example of where, you have to collect like terms and solve a math equation to get a real answer, right? So we're going to have, 2 delta t's here and 2 here as well because the half of the 4. So we're ending up with 4 delta t's equals 8. Nice easy numbers here. Divide both sides by 4. And end up with delta t equals 2. So we're finding out that it's 2 seconds, right? So therefore, it takes 2 seconds to travel between the markers, right? Yeah. So just make sure you recognize you're doing that one first, right? So this was done first, and then if you have that time, I think we'll be able to do the rest of the question, right? Because over here, we're going to have acceleration equals delta v over delta t. And we already calculated delta v. It didn't show it as well, so maybe I'll do that here as a v2 minus a v1, or separately do delta v equals v2 minus v1, right? So you could separately do this and have this be a 4 and just put a 4 in the next line, or just go ahead and do it in the work here. So the 6 minus the 2 over the time interval of 2 seconds. And so we're getting the acceleration as a 4 over a 2. So we have an acceleration of 2 meters per second squared. Whatever, I don't even need to fill all this in, to be honest. Like, I'll just leave it like that because that's quite common to, very, very acceptable thing to have. And so again, therefore, the acceleration was, or maybe you put them together to a single, therefore. So it looks like the time interval is 2 seconds and the acceleration was 2 meters per second squared. Both 2's by chance in this case, if I haven't made any mistakes. I'll just double check here. We got the 8, 2, and this was a 4. No, I think it looks good. I think I had a page here worked out in the past as well that was both 2 and 2. So I figured it was probably easier to follow if I went and just go ahead with it with you. So the equations version of this, notice we had to do the time first and the acceleration. So let's show off our equation ability and say I can basically solve for either one if I want. So let's look at V1 and V2 and delta D. And instead of having to get the time first, let's show off and do the acceleration first because we can. So that's our first time using, actually not first time because one of the questions had a little bit of a different type to it because of how I wanted to connect things earlier. But that's okay. We're gonna use this one more officially now, right? The reason we're using that one is because the information we have. So we pick that equation out, plug numbers in, and collect like terms. You're gonna have an 8 times the 2, it's gonna be a 16a. Take away the 4 from both sides, divide both sides by 16. We get that acceleration of 2 meters per second squared. Okay, confirmed. And then, so we got that second answer. We were able to get that first. And then if we're looking at getting the time, so let's keep track here. We've got V1, V2, displacement, and time we want to use. V1, V2, right? V1 and V2, displacement and time. So if we want to just go ahead with what we were given originally, we'd use this one. Of course, because we have the acceleration, we can use anything we want, right? So if I wanted to use, we're looking for the time. So we could use any of these really, because if I use this one, then I can use this one, right? If I use the acceleration, I can use the, right? If I use the acceleration, I can use the, but the one we'll use based on just the original given information would be that delta D equals V1 plus V2. It's that average velocity one. And yeah, so our average velocity times the unknown time must end up being 8. So just solve out and get your 2. Okay. Well, hopefully that seems pretty reasonable to do. A slowing down case, throwing that in there as a possible extra, but I mean, we had a type 3 slowing down. We had a type 4 speeding up. Like it doesn't really matter. The only switch to watch for there is even this delta V is a negative. Of course, we put it as a positive, right? For the right here for the height of the triangle. So yeah, I think I'll leave that for now. If you want to see that, if you need to see that one or whatever, I can put that as a help post. But I think that's probably enough to get us going. And so there's just I just did 3 of each for now. So notice that we've got a speeding up case, in the downward direction, and then this one I think is a slowing down case. So I think that the final ones here are both the slowing down ones. So if you're gonna skip it all and save for later, don't skip on these ones, right? Make sure to do the 8 and 12 because they're the slowing down case. You want to make sure you're able to do that because I think all the other ones are speeding up. But I think 6 is a reasonable amount based on this lesson only being, what is it here, 20 minutes. We still have another, it's supposed to be a 75-minute period plus, half an hour or 45 minutes of homework, right? So I don't expect to see skipping on this one. I have already pared it down. My original lesson actually had types 3 to 6 or something like that in it. So giving you smaller bits. So let's get some good practice in. All right. So there we go. If you have any questions, let me know. I'm around for you to help.